I'm gonna make some high pressure right here. Get ready for this. Shake it up. Don't do this at home. Making high pressure. You can see how much pressure is gonna build up. This thing's gonna explode like crazy. You ready? On 3, 2, 1. Whoa! And it didn't go as planned. Woo! Okay, we're going to be making an air mass, and we're going to show you how high and low pressure it forms. Air mass is an immersed body of air movement around our planet, which is several kilometers thick. It's about 1,000 miles thick, and we're going to show you when you get a cool air mass right here. We have some hot boiling water over here with some red water in it. We got some cold water here. It's going to create some unstable air. You have some cold ice water over here on this side. And you have some hot water on this side, which is now purple. What do you think is going to happen? You can see, here we go. Usually the blue is high pressure and the red is low pressure. So the red should rise over the cold pressure if it works. This didn't really work too good. It didn't work too good. This is what should have happened. This is the cold high pressure, and this is the warm low pressure. It should have mixed, and the cold pressure should have sank to the bottom, which is high pressure. The low pressure, that's red, should have floated to the top. The maritime polar cold and humid air over the maritime tropical warm humid water should have mixed together and overlapped each other. And it usually creates a storm when the cool air sinks on the bottom and the warm air on the top. The unstable air on top of the stable air creates thunderstorms. Okay, right here we have the prize valve. Like you can see, you put the wind towards your back, you put your left hand out, and that's where the low pressure is near Canada, and your right hand out, that's where the high pressure is near Florida, and the winds are coming from the westerly wind. Pressure is the weight of air above us, and it usually always goes from high to low pressure. High pressure is usually calm winds, and it's usually cool air which sinks down, and low pressure is it holds more moisture, so it rises up. It's less dense. It usually produces more winds. We get most of our weather from the westerly winds because of the Coriolis Effect. That's the way the winds travel. If you were traveling from New Jersey all the way to Arizona, you'd be going into the westerly winds, so it would take an extra 30 minutes for the plane to go because you're getting a headwind. You're flying from Arizona or California all the way to New Jersey. You're going to be flying with the westerly winds, so you're going to be flying much faster than going against the wind. In the north, the Coriolis Effect turns towards the right. To the south, the winds get deflected to the left, and those are called the trade winds. Okay, you're probably wondering why I have a map right here, an atlas and a plane, and you're probably wondering why when you fly they don't go straight in the path, they make a curve, because right here you could see with this demonstration I'm going to show you your projected path. If you start from Texas all the way up to North Dakota, you think you'd go straight, but your path gets deflected. You can see if there's no winds, this is what you think's going to happen, your projected path, that you'd go in a straight line. As we add the westerly winds or our fan today, instead of going straight, it's going to deflect to the right towards New Jersey because of the Coriolis Effect and the westerly winds. It comes at a northeasterly winds from the southwest, and it goes northeast, and also the Earth's curvature in the north hemisphere is to the right. So you can see if I go on the other side now, which direction do you think it is? If pretending this is the southern hemisphere and this is like Brazil or Australia, it's probably going to get deflected to the left still. You can see right there, it got deflected again to the left in the southern hemisphere now. Okay, you can see I'm going northeast to Middlesex County College, so you can see from our house to Middlesex County College, it should be a shorter distance because we're going to get with the westerly winds, so we should get there much faster. But I mean, back it should take longer. Okay, it's 11:35. We'll see what time it is when I get there, but I'm just gonna go normal speed, of course. 15 minutes now. 20 minutes now at 11:55. 25 minutes now, 12 o'clock. Okay, 27 minutes now, it's 12:07, and you can see we arrived at Middlesex County College, so you could see it was about 27 minutes. Going home, I think it's usually about 35 to 40 minutes, depending with the traffic, too. Okay, it's 1:55, you could see we're heading home, it should take longer. 9 minutes in, and we're barely moving because of the traffic. 15 minutes now, 2:10. Okay, it's 2:15 now, but there was 5 minutes of traffic, so it's really 15 minutes instead of 20 minutes. 25 minutes now. Okay, it's 2:26, 32 minutes later, if you include the traffic. We have about another 4 or 5 minutes to go. Cut 5 minutes off because of the traffic, to be honest and to be fair, so really 9 minutes over, but I'm surprised it's actually 9 minutes longer to come home than we started at 2:55 and then we got home at 2:37 now, but it subtracts 5 minutes for the traffic, so that's about 42 minutes going home, but going there was only 28 minutes. I was shocked. Coriolis Effect, that means if you're in North America, the water should spin counterclockwise, and if you're in South America, the force of the gravitational pull should move it counterclockwise. Here we go. You can see the spin. Look, it's starting to spin. Not too much water. Watch. You can see. Look, it's starting to spin that way. See that? That's cool. That's called Coriolis Effect. You could see the record player spinning. This is kind of like the Coriolis Effect, because you could see in the North Hemisphere it spins to the right, and then if you live in the Southern Hemisphere it spins the opposite direction. You could see low pressure rises and high pressure sinks, but you could see the lowest pressure ever recorded was 870 millibars, which was from Hurricane Typhoon Tip in October 1979, and you could see Hurricane Katrina was 902 millibars on August 2005, and also strongest low pressure system was 980. Average sea level pressure is 113 millibars, and the highest recording of sea level pressure was 1,084 millibars in Siberia in 1968. Right here we have a barometer, and it comes in 3 different ways to measure the pressure. You could measure it in newtons. Millibars is the most standard one on the Weather Channel, and also on most common weather stations they come on inches per mercury. Also an aneroid barograph with this instrument makes a continuous record of the air pressure and changes. Also rapid drop in pressure is called bombing out or bombogenesis, and most animals could feel it in their muscles and their bones, and like right before a hurricane they get nervous and shaky and they follow you around the house and stuff. Balance. If you put your left hand out, that's where the low pressure is. If you put your right hand out, it's